Okay, yeah, next is here you see homework. So homework will be posted here. If you have your book already, the homework are from the book. So you click this link, you see that those are the question number from the book. So that's for the first week, class 1, 2, 3. But also some people haven't get the textbook yet. Then for this week, the other teacher also post the questions here, which this link is, if you open, is here. Okay. Yeah, we have the questions from the textbook just in case someone haven't get the textbook yet or the textbook has not arrived yet. The questions will be shared only this week. Yes. So week 1, 1, 2, you see 1.2.1, 1.3.3 is right here, 1.2.1, 1.3.3. So they are the questions from the textbook, just the teacher got them from the textbook just in case someone didn't get the textbook yet. Okay, class 1, then class 2 here, class 3 here. So this is for the first week. Okay, everything is clear. You all know where to get the homework. Again, you get it, you do it yourself. You don't have to submit. But tomorrow's homework class, you can ask questions about this homework. Okay, everything is clear. And then now we start today's lesson. So share screen here. Okay, yeah, so everyone have your pencil, paper ready. Let's write the dates first as always. July 4th. Our class is level 2 basic, L2B, stand for level 2 basic, lesson 1. Today is lesson 1. And then as always, I like to write down the topics we are doing today. So every class I'll do the same thing. And when I do the examples, you know, some of you maybe you are the students that you cannot write and you cannot listen and write at the same time. Then you can listen first. I'll always, when I teach you, listen first, and I will always wait for you to copy. So you don't need to worry about that. If you can listen and copy at the same time, you can do that. But otherwise, you can listen first. Okay, and then if when I am pausing after each at the end of each example, you can ask me questions about the examples. Okay, but if you have other things to ask at the break time or ask at the end of class. Okay, ask, you know, you want to ask about the course, the test, and like other things, ask at the end of class. Okay, so yeah, let's start now. So the first topic is order of operation. Yeah, today, this 1 hour, we are pretty much just going to do some reviews. Okay, and then second is recall exponent rules. All those things sounds very familiar, right? Yeah, that's what we are doing today. So the first order of operation, basic thing is BADMAS. Basic rule is BADMAS. And I think you all remember what it is. But still, let's just write it down, guys. Okay, everything I write to you, please just write it because I have it very nicely organized already. Just copy everything. Although you know it, I know you guys are very smart. I know you guys know a lot of things, but still, please just copy everything. Okay, B stands for bracket, as I am sure, or most of you still remember. D stands for exponent. D stands for division. Although in BADMAS, D come before M, but actually division and multiplication have the same priority. You all know that. Same thing. Okay. Same thing for adding and subtracting. Although A come before S, but actually adding and subtracting have the same priority. Okay. So example 1 here is just evaluate. Okay. Evaluate means calculate until the end. So here question A is 5 squared plus 5 minus 3 times 4. Okay, I know this question is very easy. I'm not asking you to do it. Okay, don't go ahead of me. Okay, what I want to show you here is if we follow this, we can do each line, we do one thing. as by that mass, we should be bracket first. So here we have this bracket. So one line, we get rid of this bracket here. Next line, we do the exponent. So we have exponent here. Next line, get rid of the exponent. Next is again division and multiple. Divide and multiplication have the same priority. So we can do all the multiply and divide, but here we only have multiply. Okay, then do this multiply. Lastly, add, subtract, we have add here, then do this add. Okay, so if we do it step by step, one thing at a time, then we need that many lines. But of course, what we want is do it faster. Okay, copy this first quickly, please. Okay, everyone done? Don't have to type me a done, but I think I'm just quickly asking. I think this one is quite quick to write. Okay, what I want you to understand is that in that mass, we know adding, subtracting is the last priority. So then we know adding, subtracting are the signs that separate the terms. So here, adding, subtracting is the last step. So we must have this is one block, this is one block first, and this is one block first. At the end, we add them up. Okay, so if we have questions, so next is this question. This time we read that adding and subtracting separate the blocks. So this is a block minus this is a block minus this is a block. Okay, everyone know negative square means negative times negative. So the answer is positive. Whatever I'm writing in light gray means you don't have to write it actually. I mean, you write in your notes, but if you are writing anytime later, you have to submit homework or submit whatever, anything, you don't need to write this light gray. So just in case I'm writing this positive here, is just in case someone was wondering, where did the negative go? No, the negative didn't just disappear. Negative times negative is positive. So this is a positive 4. This is one block minus this one block is a 4 minus this one block is a 6. And next, so of course, plus 4 minus 4 just cancel. So the leftover is negative 6. Okay, write down quickly, please. Okay, next is this one. 3 minus 5, 2 plus 1 squared minus 3. So here, what we should read is that this is one block because add and subtract separate the blocks. So here we must have this big thing is one block minus this is one block. But inside this block, by that mass, you will have this bracket is one sub block, and this thing here is one sub block. So here we can simplify two things in one line, not just doing one thing at each line. Okay, so here 3 minus 5 is negative 2. This block here is a 3 and then square, so that's a 9. Okay, then this is negative 18 minus 3. Okay, easy. Write those quickly, please. Okay, next is 52 over 2 times 1 over 13 square. Okay, certainly, I know also a lot of you know how to do this, but just in case someone forgot, so I want to write some notes quickly about fractions. Quickly recall what to do. If we are adding, subtracting, the keyword is common denominator. If we are multiplying, we say to ourselves top times top, bottom times bottom. So for instance, if we have something like A over B times C over D, top times top, numerator times numerator. Okay, then we have A times C on top, bottom times bottom, which is denominator times denominator. We have BD at the bottom. If we are dividing, we say to ourselves, multiply the flip. So AB divide CD, let's say. Dividing a fraction is you multiply the flip of it. So A over B don't change. When you change the dividing to a multiplying sign, dividing C over D is multiply D over C, multiply the reciprocal, or multiply the flip of it. So once it is a multiplying sign, then you know again top times top, bottom times bottom. Okay, write those down now. Don't do this yet because I have something else to say. Okay. So anyone not done, type a letter N on the chat box, in the chat box, please. From now on, it's always the same thing. If I ask someone not done, you type me an N. Okay, and also what I mean by done is first done understanding and then done the copying is done. Okay, first do understanding. About copying is you can write quickly, you can just take a screenshot also. Okay, everyone is done. So before I do this, we know the rules for fractions operations. And next is, of course, also we know that fractions can be simplified. Of course, we want to simplify fractions because if everything are a smaller number, then just whatever you do is faster. Adding, multiply, whatever, or everything is faster. So about canceling, I want to simplify fraction. I want to write a note for that also. About canceling. So I want to remind everyone, canceling, it looks like a top and bottom that when you simplify fraction, canceling is not top and bottom. For instance, just a quick example here, 5 plus 3 minus 3, well, add 3 minus 3 also cancel. So this is not a top and bottom, this is adding and subtracting that cancel. Actually, right here, we saw it already. Okay, so if you add 3 minus 3, it's still 5. So as you can see here quickly, that is not a top and bottom then. Well, so it actually, in general, when you simplify fraction, what is going on then? Not 5, sorry, I just mean a quick example. So here, let's say we have 10 over 12. So we know we cancel top and bottom usually, right? So what is going on? Actually, the canceling was because 10 is 2 times 5, 12 is 2 times 6. And you all know that fraction means top divided by bottom. So what operations are going on here is actually 2 times the 5, the top is, and then you divide 2, and then you divide 6. What's going on here is that, so of course, all the multiply and divide have the same priority. So this is same as 5 times 2 first, and then divide 2, and then divide 6. So the canceling, this 2 and 2 cancel was exactly because you are multiplying 2, dividing 2 that they cancel. Just like you add and subtract. Add 3, subtract 3 is cancel. Multiply 2, divide 2 is cancel. That's how you cancel it. And so the leftover or the remaining simplified version is 5 over 6. Here, same thing. After you do that, that's a 5 divided by 6, for instance. Okay, so you can see that, I mean, horizontally, like this, adding, subtracting is very easy to recognize because when it is horizontal looking, it's just obvious, right? But top and bottom, sometimes it looks like top and bottom, but you all should know that it is not top and bottom. The so-called, the look of top and bottom is actually multiply and divide. So yeah, canceling is not top and bottom. The so-called top and bottom is multiply and divide. Now again, I mean, adding, subtracting also cancel, but I'm talking about top and bottom because adding, subtracting is just horizontally obvious looking. Okay, so I'm not saying always canceling is the multiply divide. Canceling can be add, subtract also, but if something look like a top and bottom, it is not because it's top and bottom, it's because they are multiplying and dividing. That's what I meant. Okay, write it down quickly, please. Okay. All right, so here, okay, let's do this now. So here, certainly, you can do multiplying the fraction is top times top, bottom times bottom. We certainly can do that. But as we said, we want to simplify first. So maybe some of you recognize 52 and 13 is cancelable. But if not, then at least we see 52 and 2 are both even number. So at least we should recognize 52 and 2 are cancelable. Divide by 2, both top and bottom. So that's a 26 and that's a 1. From then on, when we divide to be a 1, I'm not going to write anymore because, you know, dividing by 1 or multiplying by 1 just it doesn't change anything. So if you divide to be a 1, we don't have to write it. And now again, you didn't recognize 52 and 13, but you should definitely recognize 26 and a 13. So this is a 2, that's a 1. So now the top is a 2 times 1, bottom is a 1 times 1. Okay, actually, even this line is not necessary because 2, the top is 2. If the bottom is 1, we don't even have to write it. So next time you just see the bottom, you still have your short-term memory. Everything at the bottom are cancelled. Then you just have the top. Okay, finish writing those. If you have questions, you ask now. Okay, anyone not done, type me a letter N, please, on the chat box. Okay, so you can take a screenshot if you happen to write slower. Otherwise, at the end of the class, you can tell me to come back, scroll back up to this page. Okay, example 2 is about fraction, so just simplify to evaluate. Okay, simplify to evaluate. Okay, question A here. So it is 4/7 times 5 divide 6/7 times -½ Okay, you don't have to do it yet. I'm just waiting for you to write down the question. All right, so first of all, we read everything is multiply and divide, so they all have the same priority. If they have the same priority, then we just do left to right, right? So here, if we do left to right, we'll have that this is one number first. And then when we divide a fraction, we multiply the flip of it. Then here you have one number, and then multiply the negative half. Okay, so we know that it means this is a number first. Here, whatever this is a number first. And this number divide this fraction is you multiply the flip of it. And then this is one number. This one number and then multiply it. So when we divide, we only flip this one. This multiply the negative half is still multiply negative half. And so for instance, as we mentioned before, the top and bottom here, for instance, this 6 and 2 cannot be cancelled because this top and bottom relationship is not a multiply and divide. But now after we change everything to a multiplying sign, the number should be, the answer should be top times top times top times top is the top, bottom times bottom times bottom times bottom is the bottom. So here multiply, top and bottom relationship are multiply and divide. So here again, what happened is that you are multiplying 7 and then you divide the 7. That's how they cancel. Okay, not a top and bottom because they are multiply and divide. And of course here 4 and 2 multiply 4, divide 2. So that's a 2 here. So again, this is a 1, I don't bother writing it. Cross it off means this 1 already. Okay, and then lastly, I have this 2 and 6 is still cancelable. So divide by 2 here, which is a 1. Divide by 2 here, you get this 3. Okay, and so everything is done, nothing else to cancel. This number is a positive time positive time positive. What I mean by this number is the final answer. This number, this final answer number is positive, 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 negative. So the answer is negative. And now top times top times top. You all also know that 5 means 5 over 1. Okay, so top times top times top is 1, 5, 1, 1, which is 5. Bottom is 1, 1, 3, 1 multiply, which is 3. Okay, so if you cancel everything, it is lowest term already. Okay, question B, 35 minus 3 over 7, negative 1 over 6, 1 over 2, sorry, I misread my own writing because it's getting dark. I haven't turned on the lights yet. But okay, anyway, this is the question. Okay, as we said before, we read that adding, subtracting separate the terms. So this is one block, and I add this is one block minus this is one block. That's how we read it. So the first line is we can simplify this one block, add this is one block minus something. Okay, this block nothing to cancel. Oh well, then it is positive 30. Negative is positive. Positive 30 over 7. Now here again, 6 and 3 cannot be cancelled because this top and bottom is not a multiply and divide. There is a plus sign here. But inside this block, the 2 and the 4 is a multiply and divide relationship. So here you can divide by 2, and you have a 2 left over here. Okay, so the top is 1, 1, which is 1. Bottom is 2, 3, which is 6. Here, this number is that this minus, but this number is a negative whatever number. So when you minus a negative, that's the add. And nothing to cancel, so the top is 3, 1, which is 3, bottom is 7, 2, which is 14. Okay, so next, of course, we tell ourselves, adding, subtracting, we make common denominator. Are we supposed to multiply all of them? No, of course. Let's recall how we build the lowest common multiple. The common denominator should be a common multiple of all the denominator, but we want the lowest one, right? So we just have to see what factors we need, then we can build the lowest one. Okay, so 7 is prime already. Fine, 7 is just 7. The 6 is 2 times 3. What I'm doing is I'm factoring them. As I mentioned, I want to see what factors I need to build the lowest common multiple. So for 6, I need 2 and 3. For 14, I need 2 and 7. So I claim the LCM is that, again, multiple. You need to be a multiple of 7, then you need to have a factor 7 in it. You need to be a multiple of 6, then you need the factors 2 and 3. You need to be a multiple of 14, then you need 2 and 7, but we have it here. So I claim that the LCM is 7 times 6, which is 42. So for instance, you can see this is the 7 you have. You have the missing thing is you multiply by 6, then you can get this 42. So you multiply by 6 to get the LCM. The 6 is right here. What do you miss to become a 42? You miss a 7 to become the 42. So you multiply by 7, you can get to the common denominator. 14, here is your 14, 2, 7. So what do you miss? You miss the 3 to become the 42. So you can tell that 14 need to multiply by 3 to make this 42. Okay, so you can build the lowest multiple always. Okay, so we do our same thing as grade 4, grade 3, that you say, okay, bottom times 6, top times 6, bottom times 7, top times 7, bottom times 3, top times 3, right? Okay, so if you are in grade 3, maybe your teacher teach you like this. This is a 180 over 42, 7 over 42, 9 over 42. Okay, you can do that. Okay, but I don't want to do this. I mean, now we are a bit more advanced. I want to do, if you can, I will tell you actually the more convenient thing is that if you are going to make a common denominator, just make it all at once. Okay, you can skip this line. This my light gray cross out line here means that you don't have to write this line to me at all. I don't even want it. I want this directly go to this already. This green thing you don't have to write to me either. Actually, the green thing are what you should think in your head. From 7 go to 42, you need to multiply 6, then the top need to multiply 6. The 6 to here is multiply 7, so the top multiply by 7. So you keep your short-term memory only. You don't have to write everything down. 14 go to 42 is multiplied by 3, then the top multiply by 3. So I want to see this line instead. The green thing is what you should think in your head. Okay, and so of course this number is 196 over 42. Yeah, that's the number, but fraction always in lowest form, then just simplify it. I at least recognize they both divisible by 2. So this is 98 over 21, and then I recognize they are both divisible by 7. That's 14 over 3. And this is lowest term. Okay, then. Okay, anyone not done here, type me a letter N. And any questions you want to ask now. Okay, let's go to, so this is done the first part already. So the homework you are going to have are bigger numbers, but using the small numbers, I want to make sure you understand the logic in thinking them. Okay, part 2 is about the review quickly about our exponent rules. So recall exponent rules that we have learned already. But of course, I want to remind you the reasoning of it. Not only that you know how to use it, not only that you know the rules, but you actually understand the rules. So in your head, you understand what operations are going on, then you will not make mistakes. Before I write out the rules, let's fix the terms to talk about things. So we know 2 to the 3 is 8, for example, right? So we always know this number we call the base. This number we will call it the exponent, right? Those are fixed. Did your teacher ever, your previous teachers, did they ever fix what this number is called? We can speak this as 2 to the power of 3 is 8. How about this? Let's speak it as 2 raised to the exponent 3, or 2 to the exponent 3 is 8. So 8 is a power of 2. Let me call this as a power. So for instance, 8 is a power of 2, but 5 is not a power of 2. Okay, between me and you, let's call this number as power, because that's not the official way to call it. There is no official short word to call this number. It's always called, in English, it's always called 2 to the power of 3 is 8. So, but I'm lazy. I want to communicate faster. So between me and you, let's call this number power. Okay, so the first rule is, as you remember, AM times AN equals to AM plus N. It looks very familiar. Okay, so what is going on here? First, you know this rule. But I know some students, like when they try to memorize this rule, they will say, okay, when we multiply, we add. What? When you multiply, you add? Well, in your head, you are just not speaking out those. But I mean, if someone has no visual here, and then you just hear the sentence, when you multiply, you add, then it doesn't make sense, right? So actually, let's read the whole thing. I want you to speak the whole thing. Is that when we multiply powers, each of the block is a power. You see, this is a power, this is a power, right? So this is called a power. Okay. So we have a power times power is a, when we multiply powers, we add exponent. So again, don't say when we multiply, we add. Speak the whole thing. Speak when we multiply powers, we add exponent. Okay. I don't know if you are going to be in my class later, but all the things I teach actually are useful for higher level also. The thing I tell you here, this rule, why I speak it like this, is because when we learn other things, the advanced level of exponent, we will have something related to this rule. So I want you to understand when we multiply powers, we add exponent. Anyway, speak it like this, okay? So why it is that? Let's also understand why that is. So consider a squared times a cubed. We understand a squared means like a times a, and then times a cubed is a. Well, then you are just multiplying 5 of it. No wonder you just have to add them up. Okay, so every time you use the rule is that you can have this picture quickly in your head. You understand they are multiplying, then you will not do it wrong. Now, as I mentioned before, that you speak multiply is when you multiply the power, and speak add exponent, because adding, subtracting only happen at the exponent level. For instance, if we have an plus an, if the adding, subtracting happen at the base level, we have no rule for it. Okay? So similarly, of course, when we divide powers, we subtract exponent. Well, fraction is also top divided by bottom, so we can write it this way also. Okay, why is that? Let's consider a5 over a squared. a5 is a squared is a. So as we have seen before, here the top and bottom relationship is multiply, divide. So when we cross out 2 of them, yeah, we just have 3 left over. Then of course, you just subtract them. Means that when you divide, you cross out n of them, top and bottom, then the leftover is n minus n, that many. Okay? Write down everything, please. So next is this rule, AMN equals to AMN. When we have a power, when we have an exponent, we multiply the exponent. Let's consider this. That's a square, a square, a square. But we just said that when you are multiplying, you should add exponent. In your head, you know you have two of them, multiply two more, multiply two more. That's why it's total of that many. Okay, and so no wonder you have just 3 of the twos. Okay, next is whatever to the 0 is 1 if a is non-zero. Okay, what the heck is an exponent 0? Actually, you know, again, a square is that you multiply yourself twice. A to the 1 is you have 1. But a0 means empty. Like if you say it this way, it doesn't make sense. Well, so actually, of course, we can explain it this way instead. Think about a square over a square. On one hand, well, actually, I don't even have to write out like this. Whatever divide by yourself, you just get 1, of course. But on the other hand, that when we divide, we should subtract exponent by this exponent rule. Okay, so a to the 0 has to be 1 then. Clear? Okay, next is negative exponent. So you say to yourself, negative exponent is 1 over. 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 We'll just say 5 times, then we have it. Okay, and also it comes to our mind, like if we think about it, what does it mean to be negative exponent? Because you have a to the 5 is you have 5 a's written like this. So can you how can you write negative of it? Like this? Does it mean like art wise? And then you have a negative a that is show a negative, right? that you don't have it. That's what is that what it means? Okay, of course, like we have a way to explain it, not quite this. Okay, consider a2 over a5. On one hand, that is a over a. So when we cross out, we have 3 left, and the 3 left over are at the bottom. On the other hand, when we divide, we should subtract exponent. Okay, then so negative exponent means they are the leftover at the bottom. Okay, write all those, please. Okay, if you don't want to copy yet, let me finish all the rules that you copy. So here next is ABN, is ANBN. Now again, you recognize only multiply and divide have rule of multiply. Here AB means A times B, right? Nothing in between means they are multiplying. When we are dividing, you also have it. For instance, adding, subtracting don't have it. So if you have A plus BN, I have a lot of grade 12 students make this mistake. It looks like it, but it's not. Okay? No. Wrong. Bad. Ugly. No. Okay? When we are adding, subtracting, it is not this rule. No. Okay? I hope even if you are careless or someone wake you up at the middle of the night, you still will not make this mistake. I hope. Okay? Because again, our exponent rule, see here, multiply, divide, we have rules. Adding, subtracting only happen at the exponent level. Clear, everyone? Okay, why is that? Let's consider this quickly. That means AB times AB, but they are all multiplying, so you can just multiply AA first. You can multiply those two first, 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 does not matter. They are all multiplying. So then we multiply it this way, it's the same thing. So that's why it's a squared b squared. Dividing is exactly same reasoning. Top times top, bottom times bottom. Okay. Next is this rule. If you have a negative exponent, it's 1 over, so you just flip it. Okay. But this is because, again, everyone knows that 1 over fraction means you just flip it. Whoever don't know this, tell me now. I can write it. I can write out the explanation to you quickly. Otherwise, again, you see negative exponent is 1 over. But 1 over the fraction means you just flip it. That's why you just have to flip the inside. I will say it again. Negative exponent is 1 over. But 1 over the fraction is you flip it. Okay, those are the old ones we have learned before. Quickly write those down. Write the gray stuff down also, please, and the light gray here. Okay, everything I write to you, please just copy exactly this page. Okay, what was the question mark about? Alan, what is the question mark about? Do you have question? Do you hear me? Alan Chen, can you explain? Okay, so again, yeah, let's write out the whole thing. Do you understand 1 over fraction is flip it? First, do you agree to this gray line? Yes or no? Just type me yes or no. If no, then just no. Okay, anyway, I'll explain it. You don't know means a no, means you don't know it. So about 1 over fraction being that, let me explain quickly. What does 1 over fraction means? Writing here. Okay. 1 over fraction. You know fraction means top divided by bottom. Dividing fraction is multiply the flip. And so that's b over a. So again, you see 1 over fraction means you flip it from now on. Say it once again. 1 over fraction means you just flip it. If you need, write the note to yourself. So something like this, you can write to yourself. I want to encourage you guys to write your own notes also. Something I speak, but I don't write it down for you. You can write it yourself. This is a very good practice. It's a very useful tool when you go to a higher level of study. Okay, practice writing your own note. And also, you see something you understand in class, after 2 days, you will forget. It's not that because you are stupid, it's just that we are humans, we forget things. Try to notice it from now on. Okay, you will know, you get to notice that what are the things that you should write down. You need to practice. This is something takes practice. Okay, so I want to start teaching you guys now, write down your own notes. For instance, here is something you can write down. That I said 1 over fraction is you just flip it. Okay, now talk about this. AB negative n. Keep using this gray. Negative exponent means 1 over. ABN is ANBN here, this rule. They are multiply, divide, we can have ANBN here. That's 1 ANBN. And then now 1 over fraction means you just flip it. And so that's B over AN. Okay, write those down now. Or just take a screenshot, make sure you understand it. Because next I still have 2 rules I want to talk about. The new exponent rule, just in case someone haven't learned it before. Maybe it's not new, but maybe some of you is new. Okay, so take a screenshot after if you don't have time to write it. Okay, next is we have been doing integer exponent. If we have a fraction exponent? Okay, so the main thing you say to yourself is that fraction exponent is the nth root. So some of the students say that this line and this line look very similar. I want to tell you, speak explicitly, then we'll not mix them up. This is negative exponent, is 1 over. This is a fraction exponent, then you take the nth root. Okay, so they look quite similar, but you speak explicitly, this is a negative exponent, that's a fraction exponent, then you will not mix them up. Okay, so this is the main thing we understand. Then we understand what fraction means in general. One way to understand it is that we can do it as this by the ANN rule. By the ANN rule, this number multiply, you can get this, right? I mean this rule. You multiply those two numbers to get this number. So you multiply those two, you can get this number. It means that we can do it as the a to the n first, and then take the nth root. Or we can think of it as 1 over n and then m. This number multiply is also this number, using this rule again. Okay, so it means that we can take the nth root first and then raise it to exponent n. They both are the same thing. That means it should be. Okay, so now take a screenshot of this if you are not going to write it. Kacha. Okay, and then here, kacha. Okay, for the people who want to write, quickly copy them. Anything unsure? So people, here are those two gray dots. Clear? That is very good. You ask questions, but try to respond faster. Try to. I understand maybe it could be that we have a delay because of internet, but otherwise try to respond as ASAP. Okay, anything unclear, ask now. Anyone not done, type me a letter N, please. Okay. Okay, anyone not done, type the letter N again, please. Okay, so next is let's go to example 3. Just simplify and write as positive exponent. Our curriculum here is not quite same as the day school curriculum. But in the day school curriculum up to grade 11, the teachers will force you to write as positive exponent up to grade 11. So here, before we get to that level, I also want you to write as positive exponent. Okay, so example 3, question A. Here is 372 divide 326. Okay, so of course we know by bad math, this is one block first. This is not adding subtracting, but the bracket and the exponent come before the dividing. So here will be 1 block, here will be 1 block. So this is a 314 divided by 312. Now, you don't have to write to this line at all. Dividing is subtract exponent. Yeah, don't need to write this line. I mean, in the homework, you don't need to write this line. In the note, you can write it down. In the note, you just copy exactly how I write it, even though the way I draw you this light gray, and the light gray, lighter gray, I hope you just copy exactly how I write to you, because I organize everything nicely to you already. Okay, so what I'm crossing out means that when you write to me, you don't have to write. But when you copy in the note, please copy everything. We can go straight to this when we do. Of course, in our head, we know that dividing is subtract exponent, so directly that's 3 squared. Okay. Multiply 3, 5, multiply 3 square. Multiply, oh, this is a divide 3, 5, sorry. I meant to divide 3, 5. Okay, so here you can think of it as no exponent means 3 to the 1. So 2 minus 1, when you subtract exponent, then you just get 3 to the 1. Or you can think of it as you have a 3 on top and you have a 3 at the bottom. So when you cancel one of them, you have nothing left at the bottom. You cancel one of them, you have 1 left. So just cross the exponent here, means that there's only 1 3 left over. Okay, so this is the 3 here, then divide 3 to the 5, and then multiply 3 to the 4. Now, this is multiply, divide, so we just do left to right. We will have this is one number first, right? So no exponent means this is a 1. When you divide, you subtract exponent. This is one number first means when you collect them, this is one exponent first. And then you multiply it. So you have this number and then add that exponent. So what it means is we can actually collect them all at once from now on. All the multiply, divide, you just collect them all at once. You start with 3 to the 1. When you divide, you subtract exponent. When you multiply, you add exponent. That's it. Okay. So that is a -4 plus 4, which is 3 to the 0. Happens to be 1. Okay. So next is 7 squared over 7, 6. Divide 7, 9. Okay. Divide 7, 9 times 7 to 10. Okay, so same thing, you can think of it as crossing out top and bottom. But actually, the more convenient thing, as you can see, we want to use the exponent rule. Crossing out top and bottom, you will have 4 7s left over at the bottom. Everyone understand what I mean by that? Okay. But if it's at the bottom, it's not convenient to use the exponent rule. So I would rather just do that. This is a 2 minus 6, which is 7 to the -4. Divide by 7 to the 9, multiply 7 to the 20. So as we said before, multiply and divide, we just collect them all at once, starting with -4. When you divide, you subtract exponent. When you multiply, you add exponent. That's it. So one step, you collect them all. -13 plus 20, that's 7 to the 7. Okay, next example here is x -2 cubed times x. Okay, so of course, bad math here, we have x to the -6 and then times x to the 1. My question asks you to write as positive exponent. So you notice previous questions, when I have negative exponent, I didn't do that 1 over thing. Negative exponent means 1 over. But here, negative exponent, I didn't do 1 over. As I mentioned, if you have 1 over here, the 7 to the 4 at the bottom is inconvenient to use the exponent rule to just collect them all. So here, and on the other hand also, is that even here you get a negative, but after you simplify, maybe you just have a positive, then throughout the whole question, you didn't have to do the 1 over at all. So we don't want to waste the work of flipping it at the middle step. Although I asked you to write as positive exponent, I mean the final answer, you should have positive exponent. So any negative exponent in the middle step doesn't bother us. We just keep doing it. Multiply is add exponent. Here, of course, the exponent is a 1, right? So add exponent is x to the negative 5. Now this is the final answer. Then we have to flip it and flip. Here you see after we do all the work, at the end we didn't have to flip at all. So we didn't have to waste the work. Okay, finish writing those quickly. Anyone not done, type me a letter N, please. If you have question, you ask. Oh, 8:45, our class is time up. Okay, this one is way too slower than my other class. Let's quickly finish it. So stay for 10 more minutes, maybe at most 10 more minutes, we can finish it, okay? At most. I'm just saying just in case. Okay, so next is I want to simplify this. 3 to the 9, 2 to the 17. So of course, we know that we are not going to do, we don't want to do 12 times itself 8 times, okay? But we know, first of all, negative to the positive exponent, to a even exponent means the same as positive. And still, when we simplify this, we still don't want to do the 12. Yeah, so we should recognize 12 is made up of 3's and 2's. 12 is 3 times 4, which is 3 times 2 times 2. So this is a 2 square, 3, this is a 12. 12 to the 8, 3, 9, 2, 17. This is the A times B. So you have A, like 2 square, you have to exponent 8. The 3 also have to exponent 8. So we have 2 to 8, I mean 2 to the 2, and 8 is 2 to the 16, and then 3 to the 8. So of course, the exponent rules need to be common base. So compare the 2's and 2's, you cross out 16 of them, top and bottom, then the top has nothing left. You want to have the bottom has 1, 2 left, you just cross out the exponent, then you have 1 of the 2 left. Same thing here, you cross out 8 3's top and bottom, then everything are gone. But bottom, you have 1 3 left. So the top, everything is gone, is a 1. Bottom is 1 3 1 2, which is a 6. Okay. Next, quickly, I show you that about fraction exponent, whatever way you do it is the same thing. So we can do this example. If we want to calculate this, we can do a cubic root first and then square. So everyone recognize 27 is 3 cubed. Cubic root of 27 is 3. Then that's a 9. If we do this first, we can also do that 27 square first and then cubic root of it. So that's cubic root of 7 to 9, which is also 9. Then of course you can tell we prefer this one. We will prefer to make it to a smaller number first and then exponent rather than deal with big numbers, right? Okay, so they are the same thing, but we prefer this way. What if we have a negative number? Does it bother us? because cubic root is negative, but square is positive. If we do whichever first, will it matter? So if we do the cubic root first, it will be cubic root the negative 27 and then square it. Now, square root negative is not okay, but cubic root negative is okay, because we all know if you positive square is positive, negative square is also positive. That's why you can only square root positive. But if you have a cubic, cube, positive cube is positive, negative cube, negative multiply is negative. So if you want to cubic root a negative number, means that just the base itself was negative. So the base was -3. Negative and then square, that's a positive 9. Okay, so let's see if we do square first, will it change our answer? I can also think of it as this number. This is the number. You square first and then cubic root. So indeed, here we do this first, it will be a positive big number. So positive cubic root means the base was a positive. So you still get a positive 9. Again, they are same thing. So what I'm saying here is that no matter how you do it, if you do it correctly, they are the same answer. Okay, quickly write down or just take a screenshot. Okay, anyone not done, type me a letter N, please. Okay, last part is radical. Okay, so quickly remind you, radical. Root AB equals to root A root B. This rule is exactly just AB half is A half B half. Square root, if you have no number at the front, means a square root, so the exponent is 1/2. Okay, last example, A and B though. Okay, here I want to just simplify it. So root 50 plus root 32 plus 2 root 8 minus root 338. Okay, write down the question quickly. All right, so what are we supposed to do here? Or if you want to just take a screenshot at the end, then can listen to me first. Okay, so we have 3x times 2y. You know 3x also means 3 times x, right? So that is number by number, and then x by x, y by y. So when we have 3 root 2, 3 root 5, and 2 root 6 is the same thing. Multiply number by number, and then radical by radical. If we can simplify, we continue. Multiply is like this, but if we are adding, subtracting, we will say to ourselves, collect like terms, right? So here, same thing. We have to collect like radicals. If I have something like a 3 root 10, 2 root 10, then I can collect them to be 5 root 10. So adding, subtracting, we say to ourselves, collect like radical. Just like here, we'll say collect like terms. So looking like this, they are certainly not like radicals. Yeah, so we have to write them to lowest form also. Root 50, you say that, okay, we can break it as we can break it as root 5 root 10. But if you break it like this, it's not meaningful. So no, we don't want to break it like this. What I want to break, so-called, okay, like this kind of breaking it up, is I want to take out square factor. For instance, here I want to take out 25. Because root 25 is just 5. So the meaningful factor to take out are the square factors. So here 32, 32, sorry, maybe some of you recognize you can take out a 16. But if you don't, you can take out 4 first. And now you ask, is 8 is the lowest term? Well, 8 can still take out a 4. Here, 338, same thing. We just have to try factor out square numbers. So try 4, 9, 16, 25, 36, 49. Try those square numbers, and then you keep trying until 13 square is the number you can divide here. Okay, so line them up. This is a 2. Root 8, as we have seen here, is you can further break it to root 4, root 2. Root 4 is just 2. And this is a 13 root 2. So that's a 5 root 2. Here, this is a 2. So this is a 4 root 2. 2 root 2, that's also a 4 root 2. Okay, they are all like terms here, happen to be. So we collect like terms if we have like a root 2 will be like term, root 5 will be another like term. Okay, so here 5, 4, 4, which is 13 of it minus 13 of it happen to be 0. Okay, last one really. Okay, almost done. 4th root of a cubed times a to the -3 5 times square root a to the -3. Okay, if we want to simplify it, of course, the rules are called exponent rule. So we know we need to use exponent, need to turn them to exponent first to use the exponent rule. So 4th root is, as we mentioned before, that fraction exponent is take the nth root. So you take the 4th root, tell you it is the fraction 4 at the bottom. Okay, so this is a to the 3 over 4, a to the -15. Here, what is empty again? If it's empty, how do we turn it to exponent again? Well, right here you see it. Empty is square root. So square root is 1 over 2. So this is the a -3 over 2. The empty here is square root. So it's 2 here. Okay. So now we can collect them all at once. We start with a to the 3 over 4. We multiply. So we add exponent. Is multiply. So you add the exponent. Okay. And so now just, okay, add them up. Then adding is common denominator. This is a 3 bottom times 4 top times 4 plus the negative is minus, plus the negative is minus, bottom times 2 top times 2. Okay, so we have here a to the -63 over 4. Now I ask that again for our level, I want everything in positive exponent. So that's the 1 over a to the 63 over 4. Or if the question says so, you do so. If the question say you write it as a radical form, then at the end you change it back to radical form. So it depends on the question. The 4th root of it. Here, this, all 3 of them are the same thing. It depends on the question. If it asks you to write as positive exponent, then you stop here. If it asks you to write as a radical form, then you stop here. Okay, so that's it. Finish writing everything. You can take a screenshot here. Kacha. Kacha. Okay. This is our class time, Monday, Wednesday, Friday, and then our homework class tomorrow is our first homework class. So tonight you do the homework, and then tomorrow I'll see you in the homework class. If everything is clear, you type to me a bye on the chat box, then you can go. Then I'll see you next time. And if anyone not done writing, tell me now to scroll back to wherever you can take a screenshot. Everyone clear of my instruction? So if you don't understand everything, type me a bye, please, so that I know you understand my instruction. Okay, then you can go. Thank you. Bye. 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 Okay, so again, if you are not done, just tell me to scroll left, right, up, down.
All right.
Okay, bye-bye.
Thank you. Bye-bye.
Okay, bye.